Hello, my name is Tom McDougall. I'm with the Ontario Ministry of Northern Development, Mines, Natural Resources and Forestry, and today I would like to provide you with an update of the status of the Coldwater fish community in Lake Erie on behalf of the Coldwater Task Group of the LEC. The task group has participation from 12 individuals spanning 8 agencies, provincial, state, and federal. Our assessment of Coldwater fishes involves assistance from non-task group members as well. The representative species I will talk about are all described in the fish community objectives for the lake, last updated in 2020. Most of the talk will focus on 3 key species, lake whitefish, lake trout, and steelhead, which have specific targets described in the objectives, and this will be followed by a more generalized status description for burbot and cisco. In order to assess status, the task group draws on data collected from both fisheries and from fishery independent surveys. 2 key agency gillnet surveys target the eastern end of the lake when waters are thermally stratified between August and October. The Coldwater Assessment Survey fishes the 8 blue areas shown on the map, which have depths greater than 20 meters. The locations where they sampled in 2021 are shown here with blue and green circles. The Partnership Gillnet Index survey fishes more broadly in the east in both shallow and deep areas of Ontario waters. 2021 partnership sampling sites are shown here with red stars. Lake whitefish are categorized in the fish community objectives as an intensively managed species. I'll provide information from the commercial fisheries and from the Coldwater and Partnership Gillnet assessments, and will then describe modeled abundance and adult abundance relative to a target. Here we show total commercial harvest of lake whitefish in thousands of pounds since 1987. In 2021, 122,000 pounds were harvested, representing a decrease from 191,000 pounds in 2020. Of this, most, 84,000 pounds or 69%, was harvested by the Ontario commercial gillnet fishery, shown in blue. This is followed by 37,000 pounds or 31% harvested by the Ohio troutnet fishery, shown with red hatches. Harvest from other jurisdictions was negligible. In Ontario, the harvest represented 27% of the 300,000 pounds allocated to the fishery. In general, harvest has been low in the past decade, relative to the time series. This was lowest in 2017. It's worth noting that the Ontario commercial gillnet harvest, the largest contributor, has been a non-target fishery since 2014, with most of the harvest occurring in gillnets targeting walleye. This map shows the spatial distribution of those 122,000 pounds harvested in 2021. In Ontario waters, we are showing this by 5-minute commercial grid, and in US waters by 10-minute grid. The map does exclude a very small amount of lake whitefish harvested by TropNet in New York waters. So we can see that whereas harvest occurs lake-wide, most occurs in the Western Basin, and most of this occurs in the fall. By examining the ages of lake whitefish caught in Ontario's West Basin commercial fall gillnet harvest, we gain an understanding of the relative ages contributing to the current population as a whole. This assumption allows this data to be used when modeling the absolute abundance of the population. Of note again is the period between 2010 and 2017 when lake-wide harvest was at a time series low and was comprised primarily of older fish. A significant recruitment event in 2015 began to enter the fishery in 2017 as 2-year-olds. Here, we're looking at catch rates from the 2 agency gillnet assessments since 1985. The partnership index is represented by the lines on the graph, with catch rates broken out by age category. So young fish ages 0 to 2 are shown in orange with squares, while older fish, ages 3 and above, are shown in red with circles. The gray area in the background displays the catch rates of all ages combined for the Coldwater Assessment Survey. Of note, the trends in catch rates from the 2 surveys mirror each other in most, but not all years. The influence of the 2015 year class can be seen in both the age categories from the partnership graphs, and the very large spike in catch rates in the 2021 Coldwater assessment was driven by a time series high of catches in the New York waters portion of the survey. Discrepancies between the survey results may be attributable to different contributions from different stocks of whitefish. Data from the commercial harvest and from Partnership Gillnet Index are used as data sources for a statistical catch-at-age model. In this graph, we are looking at model estimated abundance from 1994 to 2021 for lake whitefish aged 3 and older. Future abundance from 2022 to 2024 is projected based on assumptions for survival and on juvenile recruitment projections. We should note that the population did hit rock bottom in 2016, and recruitment from year classes since 2014, in particular 2015, are contributing to population growth. The catch-at-age model abundance estimates were used to inform estimates of the adult portion of the lake whitefish population, described here as spawner stock biomass, SSB, shown in millions of kilograms on the y-axis. Spawner stock biomass estimates are from 1992 to 2021 as a solid line, and then projections forward to 2024 are shown with a dashed red line. The current limit reference point, or the level of SSB below which we don't want to drop, is derived from SSB estimates during the recent period of extremely low population abundance. SSB estimates from 2014 to 2017 ranged from 1.3 to 2.3 million kilograms. The limit reference point of 2.3 million kilograms is shown with a blue dashed line. So as modeled, SSB may remain above the limit reference point threshold through 2024 at current conservative fishing rates. Moving on to lake trout. Lake trout are categorized in the fish community objectives as a rehabilitation species. The current framework for thinking about lake trout rehabilitation in Erie is described in a recently finalized Lake Erie Committee document entitled A Plan to Support Lake Trout Rehabilitation in Lake Erie 2021 to 2030. In addition to recognizing the importance of sea lamprey control, the main management actions involve stocking, with targets for numbers and desired strains described. Status is to be assessed with respect to the relative abundance of adult lake trout in the Coldwater Gillnet assessment and the presence of multiple year classes contributing to the population. Toward an aspirational goal of natural reproduction, the plan recommends identifying any life history bottlenecks that could interfere with recruitment to the population. The full plan can be found on the GLFC website at this address. The number of lake trout stocked annually has been at a time series high for most of the past decades. In 2021, over 255,000 yearling lake trout were stocked into Lake Erie, according to the plan laid out in the new framework. Anticipated stocking for 2022 is shown here as the last bar in the graph. Of note, 2022 will fully realize all changes to stocking described in the new framework. So the targeted total number of stocked will increase from 250,000 a year to 280,000 a year, driven mainly by an increase of 30,000 per year in Ontario waters. And the strains stocked will all be standardized as either Lake Champlain or Finger Lake strains. Pulse stocking will be fully implemented in both Canadian and US waters. This graph describes the relative abundance of adult fish in the population as the catch per effort, or CPE, of age 5+ lake trout in the Coldwater assessment. The bars describe the area-weighted average catch per lift for all jurisdictions in the survey. The CPE for 2021 of 1.2 fish per lift represents a drop from the recent high of 2.3 fish per lift in 2020, and a drop below the lake trout plan target of 2 fish per lift. A key metric in the plan for recognizing year-to-year variation is the 3-year running average of catch rates, shown here as the red line, bounded by blue lines representing its 95% confidence limits. The 3-year running average was just below target in 2021. This graph shows the age distribution of 171 lake trout caught in the 2021 Coldwater Gillnet assessment. 25 ages of fish were observed, and this is well above the desired target of 10 as described by the plan. This graph helps to emphasize the decision to move away from stocking Slate Island strain lake trout, which are shown in light green, and which have a lower survival to adult ages. So despite being stocked since 2006, very few were observed at ages older than 6. With maintenance of a desired adult lake trout abundance from stocking, there is the expectation that natural reproduction can occur in Lake Erie. All stocked lake trout are marked with a fin clip, and most are additionally marked with an injected tag. The rate of error in marking is known. Unmarked, potentially wild-produced lake trout are captured in the Coldwater assessment each year. In the early stages of naturally reproduced contributions to a population, it was expected that the signal of unmarked fish may be hard to detect against a background of hatchery marking errors. However, the top graph here represents the gradual increase in the percent of unmarked lake trout from the Coldwater assessment after accounting for tagging and clipping error. Additionally, based on exploratory early life history surveys from 2021, we now know that lake trout eggs have been deposited in New York and Ohio waters, and at least some natural reproduction is successful to the fry stage, as fry have been captured in New York in April in 2021. Work will continue in 2022 to identify bottlenecks that might restrict the full recruitment of naturally reproduced lake trout into the population at large. I will now move on to rainbow trout. Rainbow trout are categorized in the fish community objectives as a generally managed species. The rainbow trout population, and thus the fishery, is sustained by stocking. Stocking of rainbow trout, as shown in the gray bars here, has remained relatively stable at around 2 million fish per year for much of the past 30 years. In 2021, just over 1.9 million rainbow trout were stocked into Lake Erie. This map shows numbers of rainbow stocked in 2021 broken out by jurisdiction. The fish community objective status target for rainbow trout is to realize a tributary angler success rate of 0.25 fish per hour. The last creel survey to estimate the tributary catch rates occurred in New York in 2018, where CPE was double the target at 0.56 fish per hour. However, the target has generally been surpassed in South Shore tributary creels in Ohio, Pennsylvania, and New York conducted over the past 20 years. A New York tributary creel is planned for 2022. Moving on to burbot. The relative abundance of burbot is assessed using catch rates in both the Partnership Gillnet Index and the Coldwater Gillnet Assessment. This graph shows catch rates from both surveys since 1985, with the Coldwater Assessment broken out by jurisdiction. In 2021, 54 burbot were caught in the Coldwater survey and 40 in the Partnership survey, and 6 of these were actually caught in the east central part of the lake. Catch rates in the past decade have been at very low levels relative to the previous 2 decades. During the period of highest relative abundance, CPE in Ontario waters was often notably higher than in US waters. 2021 saw a slight uptick in catch rates in Ontario waters. Low recruitment for burbot was notable in the recent past, as expressed by mean age of the population. Most of the fish caught in the gillnet surveys were old. Anomalies observed on burbot gonads led to speculation about failed recruitment. The 64 burbot aged from the 2021 Coldwater and Partnership assessments show notable contributions from younger age classes, which is a positive sign for this species. Lastly, cisco are officially considered extirpated from Lake Erie, although they were once important contributors to the Coldwater ecosystem and to the fisheries of the lake. The Coldwater Task Group continues to report on the small numbers of herring-like fishes that are observed annually. Weight of evidence continues to support the conclusion that ciscos observed in Lake Erie are the result of immigration from the upper lakes. While it was previously shown that samples collected from 2000 to 2010 resembled deep water forms from Lake Huron, bloater, and hybrids, Recent observations, documented here for 2019 to 2021, were recently shown to resemble shallow water shorthead forms. Ongoing research initiatives seek to examine the suitability of the contemporary Lake Erie environment to support Cisco. All three of the investigations listed here continue into 2022. Please be aware that Richard Krause will speak to some of this research later in this session. Finally, on behalf of the Coldwater Task Group, I thank you for your time and encourage you to consult the Coldwater Task Group report for 2021, which can be found on the GLFC website at this address. Thanks very much.